Okay, so chapter 3.2, which is obtaining information from graphs of functions. So I put a graph of a function here, some random graph of a function, and we're going to try to do an analysis of the function. So the very first, take a look here. You can see it has x-intercepts, y-intercepts, and so on. The very first question is find f0 and f negative 6. In other words, what is the y value when x is equal to 0? So f0 is equal to, so when x is equal to 0, we can see that y is equal to 3. And f negative 6 here is equal to negative 3. F negative 6 is equal to negative 3. F positive 6 equals to 0. And F11 is equal to 1. Okay? Positive 6 and 1 is equal to 0. Is F3 positive or negative? So F3 is not specifically shown on the graph. Okay, when x is equal to 3, that point is not actually shown on the graph. But we know that if we were to mark it, when x is equal to 3, it would be this point here. And that y value would be positive. And again, f negative 4 is not shown on the graph, which would be about here, right? Negative 4. And that y value would be negative. For what value is f of x equal to 0? In other words, for what values of x is the y value equal to 0? So that's all of the x-intercepts, negative 3, 6, and 11. I'm sorry, and 10. Yeah. Negative 3, 6, and 10. All of those values have a y value equal to 0. For what values of x is f of x greater than 0? So I'm going to use the graph on the side here. The y value is positive or greater than 0 for the parts highlighted in blue. So all of the y value is between negative 3. All of the x values between negative 3 and 10. No, negative 3 and 6. And all of the y values between 10 and 11 are positive. Now notice we're describing the interval on the number line on the x-axis when we're talking about y greater than 0. This is y greater than 0, but we're talking about what the x values are for that region. Okay, this is less than 6. The domain of the function the smallest x value is at -6 and the largest x value is at +11. So this domain, and both are closed dots, so the domain is between -6 to +11. The range is the lowest y value to the highest y value, so the range runs between -3 and +4. The x-intercepts are the points where the graph crossed the x-axis, so -3, 6, and 10. And the y-intercept is the one point where the graph crosses the y-axis, which is 0. Which is 3. This point right here, that point. The y-intercept is 3. How often does the line y is equal to 1/2 intersects the graph? So y equal to 1/2 is a horizontal line passing through y equal to 1/2. That's the equation of a horizontal line. We can see that the graph intersects at 3 points. And x equal to 5 is a vertical line passing through 5. And that only intersects the graph one time. For what values of x does y equal to 3? And we see there are two values of x where y is equal to 3. 0 and 3 and 4 and 3. 4 and 3. So 0 and 4. And for what values of x does y equal to -2? And we can see that those are two values here for -2. This one and this one. -2. So those two values are -6. I'm sorry, -5 and +8. +8. So this is what is meant by describing the qualities of a graph. And I know this question has many parts, but they're simple information given on the graph. Now, sometimes we have to do this algebraically, and I want to go over those parts as well. For example, given f of x equals to x plus 2 over x minus 3, x minus 6, we're going to do a few parts to this problem to see if we can answer some questions about it. Is part A, is 3 and 14 on the graph? To find out that, we would substitute 3 and 14, into the original equation. So this is x and y values, so we would substitute 14 for f of x and 3 for the right-hand side for x. This gives 14 is equal to 5 over -3. So clearly left-hand side is not equal to the right-hand side. So no, 3 and 14 is not on the graph. Part B, if x is equal to 4, what is f of x? So f of x is f4, 4 plus 2 over 4 minus 6 which is 6 over -2, which is -3. So f of x is equal to f of x is equal to -3, and that point is at 4 and -3. Part C, if f of x is equal to 2, what is x? So if y is equal to 2, we have the original equation is x plus 2 over x minus 6 is equal to 2. And we would need to solve this, so we would multiply both sides by x minus 6. Which gives x plus 2 is equal to 2x minus 12. So x is equal to 14. Okay, so let me just box the answers here. X is equal to 14, and of course that point is 14 and 2. Part D, the domain of f of x is equal to x plus 2 over x minus 6. So the domain x cannot equal to positive 6, because positive 6 would make the denominator 0, and we can't divide by 0. The x-intercepts, to find x-intercepts, set y equal to 0. So set x plus 2 over x minus 6 equals to 0. This means that x plus 2 is equal to 0, so x is equal to -2. That point is -2 and 0. FYI, in case you wondered, whenever you have a rational function, if you wanted work for this, you would take x minus 6, multiply both sides by x minus 6. That would give you x plus 2, and anything multiplied by 0 is equal to 0. Okay, so it's much easier to just take the numerator and set it equal to 0 if the right-hand side is set equal to 0 to get your answer. In part F, the y-intercept occurs when x is equal to 0. So f of x is equal to 0 plus 2 over 0 minus 6, which is 2 over -6, which is -1 over 3. So f of x, the y-intercept, is 0 and -1 over 3. And I want to also do this for a quadratic function. Example, given f of x equals to 2x squared minus x minus 1. So we're going to answer the same 6 questions. A is -1 and 2 on the graph. on the graph. So substituting, we've got 2 is equal to 2 times -1 squared minus -1 minus 1. So if we square -1, we get +1 plus 1 minus 1. So 2 is equal to 2. So left-hand side equals to the right-hand side. So yes, -1 and 2 is on the graph. Part B, if x is equal to 4, find f of x. So they're asking us to find the equation substituted with 4, which is 2 times 4 squared minus 4 minus 1, which is 16. 32 minus 4. Check my math here. 4 4 is 16 times 2. Yes. What is the point? Let me see. Something does not look right here. 2 times 4 squared minus 4 minus 1. Yes, it is right. I'm sorry. So that is 32 minus 5, which is 27. So that point is, so f of x, when x is equal to 4, is equal to 27. And the point is 4 and 27. 4 4 is 16 times 2 is 32 minus 4 minus 1. Okay. Third part, if f of x equals to -1, what is x? So essentially, y is equal to 1. What is to -1? What is x equal to? So we would set the equation 2x squared minus x minus 1 equal to -1. Add 1 to both sides. We've got 2x squared minus x is equal to 0. And do a bit of factoring here. We've got 2x minus 1 is equal to 0. So x is equal to 0. And 2x minus 1 is equal to 0. So x is equal to 1/2. So we've got essentially 2x, two values for x. And remember, this is a U-shaped graph, right? So that would come out of the graph. Now, we want to perhaps put this into the point form. So this is at 0 and -1 and half and -1 also. Part D, what is the domain? So this is a quadratic function. The domain is negative to positive infinity. You don't have to think about this. Part E, what are the x-intercepts? Set the function. Remember, for that y is equal to 0, so 2x squared minus x minus 1 is equal to 0. So factor this. I use slide and divide for factoring, which is x minus 2, x plus 1, and then I divide by, I hope you guys are okay with factoring. One of the prerequisites of this class is factoring, okay? So I'm expecting that you guys know how to factor. And since we multiplied by 2, we're going to divide by 2 here. So x minus 1, 2x plus 1 is equal to 0. Okay, now keep in mind that we have to set these equal to 0. So x is equal to 1 and x is equal to negative half. So the x-intercepts are at 1 and 0 and negative half and 0. And finally, the y-intercepts. For this, x is equal to 0. So f of x is, f0 is equal to 2 times 0 squared minus 0 minus 1. In other words, the constant term. This occurs at 0 and negative 1.